Let's talk about the arcs and chords in circles. A central angle is an angle whose vertex is in the center of a circle, as in the picture below. An arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. Basically saying, if you look at the red part of the circle, that is an arc. It is an unbroken part of the circumference of the circle. We have different types of arcs within circles. We have a minor arc, which is less than 180 degrees, and it's also congruent to its central angle. We name minor arcs with 2 points. A major arc is an arc that is more than 180 degrees, but less than 360. Notice how you can find the measure of a major arc by doing 360 and subtracting out the central angle. We name major arcs using 3 points. A semicircle is equal to 180 degrees. We also name semicircles with 3 points. This circle graph shows the types of grass planted in the yards of one neighborhood. They want us to find the measure of arc KLF. I have highlighted this arc in red, and you notice that it is more than half the circle, so it is a major arc. So we need to figure it out by doing 360 minus the measure of the central angle of the unshaded part, so the measure of angle KJF. In order to find the measure of angle KJF, we need to add the 20%, 8%, and 7%. That gives us 35% of the whole 360 degrees. So we know the measure of angle KJF is 126 degrees. Now we can find the measure of the major arc they want us to find, KLF. We do 360 minus that 126, and we get that the measure of arc KLF is 234 degrees. Now this example here, I want you to do on your own. This will be due in class. My advice is to sketch a circle and put in the different pieces so that way you can highlight the angle or the arc that they are wanting you to find. Again, make sure you do this and have it ready for class. Adjacent arcs are very similar to adjacent angles. Adjacent arcs are arcs that are right next to each other, as you see in the picture. Arc RS is adjacent to arc ST. They share point S, which can lead to arc addition. If we want to know the measure of arc ABC, we need to add the measure of arc AB and the measure of arc BC. You have seen this as well with segment and angle addition. So here, they want us to find the measure of arc BD. Again, I have highlighted this arc in red so we can identify what we need to find. Notice that it's going to be the measure of arc BC plus the measure of arc CD. We don't know either one except for the fact that measure of arc BC is 97.4 degrees because the measure of its central angle is vertical to the 97.4 degrees. And since vertical angles are congruent, we know that arc BC will be 97.4. To find the measure of angle CFD, BE is the diameter of the circle, which goes through or cuts the circle in half. So we know that the measure of angle EFD, DFC, and CFB added together will all give us 180 degrees. So we need to add the two that we know, the 97.4 and the 52, and subtract from 180. And we get that the measure of angle CFD is 30.6 degrees. So if the central angle is 30.6 degrees, we know that the arc is 30.6 degrees. So now to find the measure of arc BD, we add the two arcs together and we get that it's 128 degrees. Take a look at this one and find the measure of arc JKL. Sketch the picture, highlight the arc, and use your arc addition in order to find the measure of arc JKL. This one will be due in class. Circle or congruent circles, we can have congruent arcs. And these congruent arcs only happen when the central angles are the same. So looking at that figure there, since the central angles are the same, arc ST is congruent to arc UV. So let's look at some theorems. If we have a circle or congruent circles, if we know that we have congruent central angles, we know we have congruent chords. If we have congruent chords, we know we have congruent arcs. And if we have congruent arcs, we know that we have congruent central angles. So they all affect each other. So here, we know that TV is congruent to WS. We need to find the measure of arc WS. Well, if we know that chords are congruent, we know that their arcs are congruent. So we know that arc TV is congruent to arc WS. And if the arcs are congruent, their measures are equal. So we can substitute in, and we can solve for n. And once we get n, we can substitute back into arc WS, and we get that the measure of arc WS is 88 degrees. Let's bring in some other vocabulary. We have ray PT, and it bisects angle RPS. We need to find the length of RT. Well, since ray PT bisects the angle, we know we have congruent angles. And if we have congruent central angles, we know that we have congruent arcs. And if the arcs are congruent, we know the segments are congruent. So now that we know that RT is equal to TS, we can substitute in and we can solve for X. And since we still need to find the length of RT, we can substitute back in and we get that RT is 12 units long. So now I want you to look at this one, pause the video and give it a try. This one will also be due in class. Here's another one. So this one will be due in class as well. One more theorem I want to take a look at. It says in a circle, if a radius or a diameter is perpendicular to a chord, then it bisects the chord and its arc. So looking at this diagram, we notice that the radius CD is perpendicular to the chord EF. Therefore, we know that ED is equal to DF, since that radius bisects the chord. We also know that arc ED is congruent to arc DF. The converse is also true. If we know that a chord has been bisected, then we know that the bisector is the radius or the diameter. Let's take a look at how this works. We need to find the length of NP. Well, hopefully you notice that RM is a radius and it's perpendicular to the chord, so NP is bisected. We get that the radius is 17 since 8 plus 9 is 17. But let's draw in the radius RN. And since all radii are congruent within a circle, we know that the length of RN is also 17. Hopefully you see a right triangle, RSN, because now we can use Pythagorean theorem in order to find the length of NS. So we get that NS is 15. And remember we said that if a radius is perpendicular to a chord, it bisects the chord. So if NS is 15, which is half of NP, we can double it and we get that NP is 30. Now I want you to give this one a try and have it ready for class. Remember, if you have any questions about any of these theorems or how to use them, please come see me. We can work on them together. Good luck!